Hello, in this video we are going to talk about the Pocket-RC4 card cipher. This card cipher was invented by Matthew McCogg, apologies if I'm not saying his last name correctly, who also invented the card chameleon cipher, of which I've also done a video for. Both Pocket-RC4 and card chameleon are very similar in design. The difference being that card chameleon would be called an auto key cipher, where the algorithm is dependent upon the message that you're either encrypting or decrypting. So we would be looking for a character, work through the algorithm, and a character would be output as a result. Pocket-RC4, on the other hand, is a pseudo-random number generator that generates a key stream of numbers independent of the message that we are encrypting or decrypting. So in this case, similar to solitaire and some other card ciphers, I need to convert my message to their numerical values for each character. So I have a table here with the English alphabet, A through Z, and its numerical values of 1 through 26. Also, the card values are assigned values 1 through 26 based on their suits. Hearts and spades are their face values, ace low, and the clubs and diamonds are their face values plus 13. So the maximum value in this deck is 26, and 2 cards are assigned each value. So let's go ahead and set up the algorithm. I have the common message that we've been encrypting throughout the other videos, do not use PC. And we need to convert each character to their numerical representations. So D has the value of 4, O has the value of 15, N is 14, and so forth. Okay. So converting each of these would produce the following in that case, provided I did everything correctly. Now we're ready to work through the key stream algorithm. So I have my deck of cards. This was riffle shuffled 12 times to produce hopefully a good random order of cards that would maximize the entropy in the deck. And what I need to do is separate this deck into black and red piles. I need to do this deterministically, so there is zero ambiguity in the process. So that if I were to separate, or to key, we'll call it keying the deck. If I were to key this deck, my recipient would be able to key it exactly the same way, with no ambiguity. So the way we're going to do this by creating the 2 piles is by separating, creating a black pile and a red pile, and we're going to be doing it 1 card at a time. So I'll place the 8, and then the ace, and then my 9, and each black card 1 at a time. I'll never set down a clump of cards. Again, we want this algorithm to be fully deterministic with zero ambiguity. So we will go ahead and create these 2 piles, 1 at a time, until we've exhausted the deck. Now my 2 piles are created. Now what I wish to do is combine those piles into one where the cards are strictly alternating black and red, with the black on the bottom and the red on the top. This is the exact same process that I would be doing for card chameleon if you've watched that video. So black first, then red, and we strictly alternate 1 card at a time, black, then red, black, then red, and continue to work our way, combining both the black and red piles into a single pile. What's interesting about this process is when we are finished, we've kept the order of the black cards. We've just shuffled them or not really shuffled, we've moved their positions with respect to the red cards. And the red cards the same. We've kept their order exactly the same as the initial shuffle. We've just moved their position with respect to the black. But their order still remains the same. 3 still follows after 9, the queen after the 3. This is the same order as it was when it was riffle shuffled. We've just forced it to now be black, red, black, red, black, red. All right, so we're black, red throughout the deck. We are now ready to start producing our key stream of bits. So let's go ahead and start working on that then. I'm going to bring this, well, no, I'll keep it behind the paper. All right. The first step in my algorithm is to sum the bottom red card with the top red card and assign that as the variable j. This is what's used in the PDF of Matthew's master thesis, so we'll stick with that same nomenclature. So the bottom red card is the 5 of diamonds, and the top red card is the 9 of hearts. The 5 of diamonds has a value of 18, and the 9 of hearts has a value of 9. So 18 plus 9 is 27. Now, I only have 26 total possible values, and my next step is to locate the black card for j. Because I don't have a black card for 27, I need to do modular 26 arithmetic. That means I need to keep the values bound within 1 and 26. So because my value is 18 plus 9, 27, I'm going to subtract 26 from the value, and that will give my resulting value 1. The 1 is the ace of spades, so we'll look through the deck as per step 2 for the ace of spades. We found it. Step 3 is to sum the red card above j, or our ace of spades, with the top red card and assign this as k. So my red card above the ace of spades is the 6 of diamonds. The 6 of diamonds has the value of 19. The 9 of hearts still has the value of 9. 19 plus 9 is 28. Doing modular 26 arithmetic, 28 minus 26 is 2. So I go ahead and write down 2 for my value. That was the fourth step, was to write down my value k. The fifth step is now to swap this red card that I just discovered with the top red card. So I'm going to swap this 6 of diamonds and 9 of hearts. Okay. And then the final step is to move the top 2 cards to the bottom of the deck. So we'll move those top 2 cards to the bottom. We've just completed a full round of the key stream algorithm, and we are ready for the second round to encrypt my O. So again, we sum the bottom red card with the top red card. So the 6 of diamonds plus the 3 of diamonds, that would be 19 plus 16. That is 35. 35 is outside of my 26, so 35 modular 26 arithmetic is 9. So I'm going to find the black card for 9, which is the 9 of spades. So I look through the deck for the 9 of spades. Close to the bottom. And I sum the red card above it with the top red card. So the red card above it is the 9 of diamonds. The 9 of diamonds is 22, plus the 3 of diamonds is 36, or 16, pardon me. 22 plus 16 is 38. 38 mod 26 is 12. So I go ahead and write down 12 for my value. And then I swap this red card I found with the top red card. And then I move the top 2 cards to the bottom of the deck. All right, we'll do this a couple more times. I think you should be familiar with the algorithm by now. We'll do this, maybe we'll encrypt N and O, and then we will look at how the result comes out with my ciphertext. So I'll sum the bottom red card with the top red card, the 9 of diamonds and the queen of diamonds, 22, 25. That is 47. 47 mod 26 would be 21. So I find the value, the black card for 21, which is the 8 of clubs. I can see that there, the 8 of clubs. I sum the red card above it with the top card, 6 of diamonds plus the queen of diamonds. 19 plus 25 is 44. 44 minus 26 is 18. So I write down 18. And then I go ahead and swap my two cards, move the top two to the bottom, and I encrypt the next letter. Sum the bottom red card with the top red card, 6 of diamonds, 19 plus the 7 of hearts. 19 plus 7 is 26. In this case, I don't need to subtract 26 to make 0. I don't have a value for 0. But I do have a value for 26, and that's the king of clubs. So I'll go ahead and look for the king of clubs. I found him. Red card above him is the 10 of hearts. 10 plus 7 is 17. 17 mod 26 is still 17. So I write 17 down. Swap that red card with the top red card. Move the top two to the bottom of the deck. We'll do one more. We'll encrypt my T. So I sum the top red with the bottom red. 10 of hearts plus a 9 of hearts is 10 plus 9. That's 19. I find the black card for 19, which is the 6 of clubs. There it is. I sum the red card above it with the top red card. The 8 of diamonds is 21. 21 plus 9 is 30. 30 mod 26 is 4. So I write down 4 for my next key stream value. Swap the card I just found with the top red card. Move the bottom two, and I am ready to go. All right, we'll stop there. That is the Pocket-RC4 algorithm. So now that I have this, these values, and I would continue to go on as I work through the algorithm, I'm now going to add these mod 26, which, just like we've been doing, if the value is larger than 26, I need to subtract 26 to bring it within range. So 4 plus 2 is 6. 15 plus 12 is 27. 14 plus 18 is 32. 15 plus 17 is also 32. 20 plus 4 is 24. And I would have more values for the final 5 characters. I need to minus 26 in a couple spots because those values are larger than 26. And the final result is 6, 1, 6, 6, 24. So my ciphertext message for this, this specific key and the specific message would be 6 is F, 1 is A, F, F, and 24 is X. So far that is the ciphertext. Okay, and again we would have additional values. All right, let's pretend we're the recipient now, and let's go ahead and decrypt that message. We have the same shuffle order, but we haven't prepared the deck, so we're going to prepare it really quickly. Just like we did with the first deck. Being careful not to mess up the order of the cards. Okay. Go ahead ahead and black then red. Remember, black is on the bottom, red is on the top. Remember, we did this deterministically, one card at a time, so I can set up my deck the same way the sender did. So, no ambiguity. All right, we've prepared the deck. We are ready to go. So at this point, I need to convert my ciphertext into values. So we thankfully have those values above us. So I'll just repeat those here. Okay, and we would have additional values for the rest of my ciphertext message. We go through the algorithm now. Sum the bottom red with the top red, 5 of diamonds, and the 9 of hearts. 18 plus 9 is 27. 27 minus 26 is 1. The black card for 1 is the ace of spades. I now sum the red card above that. So the 6 of diamonds is 19, plus 9 is 28. 28 minus 26 is 2. So I go ahead and put 2 as my keystream algorithm. Swap the cards, move the bottom 2, go again. 6 of diamonds and 3 of diamonds. 19 plus 16 is 35. 35 mod 26 is 9. So I need to find the 9 of spades. There it is. Red card above that is the 9 of diamonds. 22 plus 16 is 38. 38 minus 26 is 12. So I write down 12 for the next value. Swap those cards, move the top 2 to the bottom. Go again. 9 of diamonds plus the queen of diamonds. 22 and 25 is 47. 47 mod 26 is 21. So I need to find the 8 of clubs. I can see it there at the bottom. So the red card above that is the 6 of diamonds. 6 of diamonds, 19. 19 plus 25 is 34. 34 mod 26 is 18. So I write down 18. Swap these cards. Move the top 2 to the bottom. Go again. 6 of diamonds is 19. 7 of hearts is 7. 19 plus 7 is 26. The black card for 26 is the king of clubs. The red card above that is the 10 of hearts. 10 hearts plus 7 of hearts. 10 plus 7 is 17. 17 mod 26 is still 17. So I write that down. Swap those cards. Top 2 to the bottom. Last one. 10 of hearts plus the 9 of hearts. 10 plus 9 is 19. Find the black value of 19, which is the 6 of clubs. The 8 of diamonds plus the 9 of hearts. 8 diamonds is 21. 21 plus 9 is 30. 30 mod 26 is 4. So go ahead and write down 4. Swap these 2 red cards. Top 2 to the bottom. All right. If I've done everything correctly, and we would continue to go with the rest of the message, if I have done everything correctly, then I should be able to subtract these and get the same values that the sender had. So 6 minus 2 is 4. 1 minus 12 is a negative 11. 6 minus 18 is a negative 12. 6 minus 17 is a negative 11. 24 minus 4 is 20. These values are too small, so we will add 26 to them. And our final value is 4. Minus 11 plus 26 is 15. Minus 12 plus 26 is 14. Negative 11 plus 26 is 15, 20, and so forth. If I were to convert these, 4 would be D, 15 is O, 14 is N, 15 is O, 20 is T, so forth. So we successfully decrypted our message. I should get do not use PC. To finish, as a successful decryption of the message. So that is the Pocket-RC4 algorithm. As you can see, it does require a little bit of math. It might be helpful to have a little calculator with you so you do your addition and your subtraction correctly. As you could probably imagine, if you make a mistake in your addition or subtraction and you look for the black card of that mistake, then you will be executing the key stream incorrectly. You will get a different value than what you should be getting, what you should expect. And as a result, this propagates throughout your message. So as soon as you make your first mistake, you're irrecoverable. And you will not be able to successfully encrypt or decrypt your message. So this is something you want to take slowly and make sure you do correctly. And again, you will want to be familiar with your modular arithmetic. So in this case, modular 26. As an observation, I have noticed, like Card Chameleon, that this card cipher probably executes a little bit faster than some of the others. But due to the addition and the subtraction, it is very easy to make simple mistakes, simple errors. So that's probably where you want to be careful, is in that addition and subtraction. Other than that, I really like this algorithm. If I were to take a pick between Pocket-RC4 or Card Chameleon, I think I prefer Card Chameleon just because I don't have to deal with the arithmetic, and it becomes pretty easy to recognize what card represents which character in the alphabet. Unlike this, there's a lot of numbers to keep track in my head, and it takes a little bit longer to recognize by sight a card's value. However, that is the Pocket-RC4 algorithm, and that's all I've got. If you have any questions or comments, leave them below. Other than that, have a good day.